Hello, today we're going to do independent and dependent events. The previous section we did mutually exclusive and not mutually exclusive. Today we're doing independent and dependent events. Let's see what's going on with my thing here, sorry. Independent and dependent events, the key to it is an and. Whenever you see an and in probability, you're going to multiply. So anytime you see the word and, you're going to multiply. Just like mutually exclusive and not, there's two different ways to do it. If you have an independent event, you do it one way, and dependent, you do it the other way, do it another way. Okay, independent are easy. Independent events happen when you do A and you do B, and they have no effect on each other whatsoever. So you're going to do two things because you're going to do A and then B. So you do one and then you do the other. So all you have to do is do this one, and then you're just going to multiply them together in the end. So independent is super easy. Here are examples of independent. Rolling a die and getting a 6, and then rolling a die and getting a 3. If you roll 2 die at the same time, it's the same thing. Or if you roll 1 die and then another die, same thing. These are independent. Each roll of the die is independent. Drawing a card from a deck and getting a queen, replacing that card, shuffling, you have to shuffle, and then drawing a second card and getting a 7. They have no effect on each other. The key to this one is the replacing and reshuffling. So if I replace, it has no effect on each other. If I don't replace, then that's something called dependent, and that's what we'll do next. Okay, so here's an example. I'm going to flip a coin and I'm going to roll a die. I'm going to find the probability of getting heads on the die and a 4 on the heads on the coin. Did I say? Oh, sorry. Heads on the coin and a 4 on the die. So just do each probability separately. The probability of heads on a single coin is 1/2. And means multiply. These are independent. They have no effect on each other. This getting a heads or tails does not affect what you get here with the die. And then getting a 4, 1 out of 6. Do your two individual probabilities, multiply them together, 1/12 in the end. Example 2, a card is drawn from a deck and replaced. So since it's replaced, we're going to be doing independent. A second card is drawn. Find the probability of getting a queen. Not sure why that's acting up. So we're going to do a queen, and then, so we're going to multiply. There we go. I'm not sure what was happening. Queen, and then an ace. So we multiply the probability of a queen. There are 4 queens in the deck times an ace. We're independent, remember, because we're replacing 4 aces in the deck. You can simplify before you multiply, or you can multiply top times top, bottom times bottom. Remember that you have something called the math frac button. So if you hit the math button and then the frac button, it'll simplify fractions for you. So if you type this in and then hit math frac before hitting enter, it'll simplify everything for you. But 4 out of 52 is really 1 out of 13 times 1 out of 13. You get 1 out of 169 if you simplify before you multiply. All I did was simplify this. Okay. The next one, a Harris poll found that 46% of Americans say they suffer great stress at least once a week. If 3 people are selected at random, find the probability that all 3 say they suffer great stress. So we want to say that probability of all 3 are basically stressed out. Okay, so if you randomly select from a large population, it should be that every single person that you select is independent of each other. You're not selecting from a small group of people in a doctor's office or a classroom. This is generally saying that all Americans. You can assume that each one of those Americans, if randomly selected from from the United States would be independent of each other. So the first person that would be stressed out, 46. Third person, second person, third person. Basically, it's just 46 to the third power. And when these get this big, you can just change them into decimals. That's fine. So if you randomly selected 3 people out of the population, about 9.7 or 10% of the time, all 3 people would say that they are stressed out. Okay, so those are the easy ones. Those are independent. Now we're going to do the harder ones where they're dependent. Dependent events are still an and, so we're still going to multiply. And if I cover this up, there's your independent that you just did. You did the probability of A times the probability of B. Now we're going to consider this one to be dependent. So let me erase that, what I just did. Oh, I highlighted instead of erased. Okay, so what we're going to do here is still multiply. So we're going to do the first probability. Then we're going to multiply, and then we're going to do the second one. This means that I'm going to do B, given that I've already done A. That's what that line means, given that I've already done A. So this second probability is dependent, that's why we call it dependent on what happened first. Okay, so when the second one is affected by what happened first, we call that a given. Here's examples. If I draw a card from a deck, and now I'm not going to replace it, and then I draw a second card. The first card is independent. It's my first draw. If I don't replace it, it changes the probability of the second card, because when I first draw from the deck, there's 52 cards. If I don't replace it, now I have 51. So it changes this second probability. Selecting a ball from an urn, not replacing it, and then selecting a second ball. So anything where you're not replacing, what's happening is you're changing how many things are inside there, how many cards are in the deck. So it changes your denominator, at least your denominator. Being a lifeguard and getting a tan. If you're a lifeguard sitting outside, I just spent the week in Ocean City. If you're a lifeguard sitting outside all day long, you have a higher probability of getting a tan. So the probability of getting a tan is dependent on what this first thing is. Okay, having high grades and getting a scholarship. People that have high grades tend to get more scholarship money. Okay, so let's take a look at this. In a shipment of 25 microwaves, 2 are defective. If 2 ovens are randomly selected and tested, find the probability that both are defective if the first one is not replaced after it has been tested. Okay, so we want the probability of 2 defective microwaves. All right, so let's say we have this shipment of microwaves, and we're going to pull the first one out. There are 2 defective ones, so we're going to pull one out, and we want both of them to be defective. There's a shipment of 25. All right, how many are defective in that shipment totally right now? 2. So the first time I go in there and I pick out of 25 microwaves, 2 of them are defective. So that's my probability for the first one. All right, I'm not going to replace it. If I find a defective microwave, I don't put it back in. So now, instead of 25 microwaves, I only have 24. And remember, I pulled one of the defectives out. So now I only have 1 defective in there. So I then just take my 2 fractions and multiply them together. Let's go back over that again. I have a total of 25 microwaves. I pull one out. I want both of them to be defective. So if I pull a defective one out, the first chance of pulling a defective is 2 out of 25. I'm not going to put it back. I have 24 microwaves left sitting there. And now I pulled 1 defective out, so I only have 1 left in there. All right, so you can simplify whichever way you want to. You can cross simplify. You can just put it in your calculator. That this comes out to be 1 out of 300. All right, so let's look at this. Worldwide Insurance Company found that 53% of residents of a city had homeowners insurance with this company. Of those, 27 also had auto. If a resident is selected at random, find the probability that they have both home and auto. So we want to find the probability of home and auto. Probability of home was 53%. Probability of auto of the ones that had the home was 27%. Multiply them together and you end up with 14. In words, this is what this means. Probability of home times, and then probability of auto, given that those people have homeowners insurance. Okay, so that means that 14% of their clients have both home and auto. So try to think of this as a dependent probability with this example. It's easy to do this math-wise. You just multiply your two decimals together, but think about what this means. So think about you have 100 people in a room. Out of 100 people, you say, hey, who has homeowners insurance? And 53 stand up. All right, so out of that, 53 are now standing in the room. Then you say, okay, of the people that are standing, how many of you have auto? 27% of them have auto. So that means out of the whole room then, 14 people are left standing. Right? So you say in a room of 100 people, how many people have homeowners insurance with us? 53 people stand up. Now you have 53 people. Inside of that 53 people, 27% of them also have auto. So when you say, okay, now of the people that are standing, who has auto also? 14 people stay standing. All right, last example with cards. Okay, these cards problems that you do, I would just, if it was me, I would just go through and just multiply them together and change them to decimals. It's just probably easiest to do that. So there are 3 cards drawn from a deck and not replaced. We're going to find the probability of the following. So we want 3 jacks in a row and we're not replacing. Okay, so 1 card and then another card and then, did you hear the and, the multiplication, and then another. All right, first jack, 52 cards. We want 3 jacks in a row. Inside the deck of cards, 4 jacks. Don't put it back. You now have 51 cards. You pulled a jack out. Now you have 3 jacks. 50 cards now, because you've already pulled 2 cards out. You pulled 2 jacks out. There are 4 jacks in a deck. You have 2 left. You can go through and just change these. These are so huge. You can just go through and change those to decimals if you want. I have the answer written as 24 out of 132, 600. You can probably just change that to a decimal and not worry about the math frac right now. Okay, let's look at the next one. An ace, a king, and then a queen in that order. Okay, so we're going to pull the ace out first. 4 aces out of 52. A king, 51 cards we didn't replace. So 51 cards left, but there's still 4 kings in there. We pulled an ace out on that last one. Last one, queen. Pulled 2 cards out already. We're left with 50. We pulled an ace out, a king out, and now a queen. There's still 4 queens left. Okay, so if you multiply those 3 together, you're going to end up with, I think, 64 over 132,600. Like I said, you can just go through and change those to decimals. I'll go back in a minute. Okay, last one. Here we go. A spade, a club, a spade, and a heart. Okay, a club, a spade, and then a heart. 52 cards, 13 clubs. 51 cards now because we pulled one out. Still 13 spades. Next one, 50 cards left. And a heart, 13. This is really huge. This is like 2,197 over 132,600. And if it were me, I would just change that to a decimal. That is the section on independent and dependent.